Okay, welcome back to another section. Today we'll be discussing on the different types of support in foundation. This is a very important aspect, especially for the structural engineers, the building designers. It is very, very important that you understand the foundations or the types of support you have in foundations. How do you know, okay, this particular foundation is has this kind of support and this has this kind of support. Okay, so and how you able to understand this is by knowing the interaction between the soil and the foundation. Your footing, how does it interact with the soil? Your raft, how does it interact with the soil? So by understanding this behavior, you'll be able to design. Um, your design will be real. So by understanding this, you'll be able to have a realistic design. Especially for those that uses the um, portal structure. You normally model your foundation with a default setting, which is the fixed support. But in all your choice or in all your design, is your foundation actually fixed support? Okay, so you see that when you know these types of support, you're able to have a realistic design by modeling the right support, not always the fixed support that we do model. Okay, so if you like what we do, please subscribe, like, comment, and share to those you feel it is necessary they get this information or knowledge. So um this uh section is going to be in part one and part two. But this is currently the part one. In part one, we try to understand these the types of support. How do you identify them? What is the how does the soil and the foundation, how do they interact? So in part two, we would now take a design. I'm going to show you guys a design in total structure where we compared the results of modeling with a fixed support and modeling with a pin support to compare the difference. And also, we will now see what actually or what effect does your place beam, your 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 ground beam or your foundation beam or your tie beams, whichever language you, you understand better, you're able to see by the demonstration, you're able to see what they actually do to your structures. Because you normally have this question now, what do we even provide plate beam? Some people say that okay, plate beam is not necessary or plate beam is necessary. So by the end of the party two, you'll be able to know if plate or tie beam or your ground beam, foundation beam, if it is necessary or not. And you're able to determine also when it is necessary to use this type of beams in your foundation. Okay, so let's let's get started. Yes, so we start by trying to understand what is a support, especially what we are doing is in civil engineering. So we want to know what support is in civil engineering, and we can see that support in civil engineering have different definitions depending on the context. So we have the two types of definition of what support in civil engineering. So when we come to construction, which is the first one, what is a support? And you can be seeing that a support can mean physical element that holds something up temporarily or permanently. So an example is when doing your formwork when you want to cast. your slab, for example, you provide a prop to be able to support your formwork. So you see that the prop now serves as a temporary what support. Then we can have again a beam resting on a column. So you see that the column acts as a support as well. An example again, a bridge pier supporting the bridge deck. So that is another meaning of support and is classified in under what in construction terms. So another type of support we can have is in structural what analysis. In structural analysis, you have a different definition, and it is defined that a support defines the boundary condition of a structure. That is deep. So what does it actually define? So you see that your support defines or determines the degree of freedom, that how restrained is your structure. It also defines the structural behavior. How does your structure behave? The type of analysis required and the stability of what of the system. So we are talking about the degree of freedom, which we are going to discuss in the next slide, because we are mainly concerned about the meaning of support or support in structural analysis. We are not focusing in construction. So in the next slide, we'll be able to understand better the boundary conditions that the support defines in the structure. So now we can say that in general, we can say a support, which is we are trying to give the full meaning of support to incorporate both the construction aspect terms and in structural what analysis. So we can say that a support is a physical element or boundary what condition. So it has specified both the meaning in construction and also in structural analysis that restricts movement of a structure or holds up a structure and transfer loads safely. So this incorporates both construction and structural analysis terms. So as you can see from the picture that the loads from the slab is being transferred to to the beams, and the beams take it to the column to your footing, which is the foundation, and then from the foundation to the soil. And you can also see that this column actually supports this beam. This beam supports this slab. This column is being supported by the footing, and the footing is being supported, and the whole structure is being supported by the what? The soil. So in that case, we decided to go further to understand this support in structural what analysis. And we have defined that a support determines defines the boundary condition of a structure. So and now we begin to look at the different type of support in structural what analysis. So the first one is we have what we call the roller and the simple support. And this type of support allows movement in all directions. Okay, so we have three directions or the three movements. We have the upward movement, which is the vertical direction. Then we have the horizontal what movement, and also we have the movement. So you see that when you make use of this roller or simple support, you see that there is allowance of movement in all directions except the vertical. So what it means that when you try to go in the horizontal direction, nothing stops you from moving that way. You are free to move. When you try to rotate, nothing stops you from rotating. But when you try to move in a vertical direction, you see that the soil or whatever you the When you're trying to move in a vertical direction, you see that the soil or whatever the object is resting on will prevent it from going down. Just like as you can see from this picture. See why the reason why this simple support and the roller support are classified as one is that they both behave the same way. So you see that you can easily go in this direction, you can easily rotate, but you cannot go downward. That is the vertical direction. Likewise for the simple support. So another type of support we have is the pin support. He said the pin support doesn't allow translational what motion, but allows rotation. So you see that the translational motion is the vertical movement and the horizontal movement. As you can see from the picture, you are not allowed to move horizontally, you are not allowed to move vertically, but you are allowed to what rotate. So this is the symbol for the pin support. This is the symbol for the roller. This is symbol for simply simple supported or simple support. So the third one is the fixed support. So you see that the movement in all three directions is not allowed. So you're not allowed to rotate, you're not allowed to move up, or you're not allowed to move horizontally. So since we have understood the meaning of support, the types of support, now let's now understand the support in foundation, which is the main goal or the main direction we are heading to, the support in foundation. So the structural analysis, the support condition of a foundation depends on what? Soil to structure what? Interaction. So as I've said that how the soil behaves together with the foundation or the structure, we will now be able to determine the type of support we have. And that is why it's very, very important you understand how your foundation will interact with the soil. And this interaction depends on the nature of the site. What are the soils or what are what are the soil profile of that site? So you don't expect in a clay site that has clay sand, clay soils, and where we have rocks to behave the same way. Understand? So that is why it's very, very important. So, which I've explained also that the soil structure, the soil to structure interaction simply means how the soil behaves when there is a load on it. I've explained that. We all know in real life, soil is deformable. Yes, soil is very, very deformable. Means that, for example, if you step on the soil, it will compress. That means it can deform. It's not rigid. So, and what this means is that foundations settle, foundations may rotate slightly, and soil behaves spring-like resistance. Okay, so because of this, because once there's like I've given an example that if you step on the soil, it's going to what deform, going to compress. That is deformation. It is not rigid. Not like when you step on the stone does not compress. Now, because of this deformable character, when there is a load on the soil, the foundation now will what settle. The foundation may also what rotate slightly, and the soil will now provide a spring-like resistance. We are going to explain what the spring-like resistance means in the next slide. So I get on to something. Then the deformation is excessive. It's soft clay, loose sand, small rock, or dense soil. Okay. Then from what we have explained so far, from this soil to structural interaction, the deformation of the soil, and the soil acting like a spring-like resistance, become from this behavior, which now gives birth to what we call the support in foundation, which is the pinned and the fixed support in foundation. So the soil to structure interaction give birth to these types of support. In foundation, you have the pinned and the fixed support. So the diagram shows when there is a load on the soil, there is cracks, there is sliding, and the other stuffs like that. All right. So now, what does it mean that soil has a spring-like resistance? So when we say soil behaves like a spring, we mean that the soil resists what movement proportionally to how much it is what compressed, just like a mechanical spring. Then let's look at an analogy, which says think of a foam, like your bed. If you press it slightly, it gives more what resistance. If you press it more, resistance increases. So likewise, the soil behaves that way, and that is the model, or that is the idea that the Winkler spring model is being used. We use the Winkler spring model in RAPS foundation design. So, and that is the analogy of what that model, that the soil behaves like a spring. The more the pressure, the much the resistance it gives, which is actually true in the sense that since the soil is deformable, the more you compress it, the more the soil gives back more resistance. So, and that is why you do your compaction. The compaction is compressing the soil, and when it compresses the soil, it increases the density of that soil. By so doing, it gives more reaction. Okay, so we are trying to look at it. We are trying to relate it now to the foundation we to our foundation. For example, the footing. Then, if a footing settles, let's say the footing settle 1 mm, the soil gives what small reaction. When you increase the settlement, you see that we have more or larger reactions. So why does it matter? Why does this matter? So if the soil is modeled as spring-like, what does it do? The columns may rotate slightly, footing settles, lateral drift increases slightly. So, so what you're trying to say that this spring-like behavior give or bet the type of support, which is what the pinned support, because the soil deformed. Because of this deformation, it will now behave like what a pinned support. Because in a pinned support, the in a pinned support there is rotation, right? Which is lateral what the columns may rotate, and by the column rotating, it will increase the lateral what drift. Then the footing settles as well. So this is just an example of the Winkler spring model, and this is what they mean by vertical spring. So this is your house foundation, which is being designed using this model. So now, how do we determine if a foundation is pinned or fixed? How do you know this, or how do you identify this type of what support? Because by identification, you model right, and when you model right, you have a realistic design. Not like when we normally use the default setting in product structure as a fixed support. But most times, or sometimes, the foundation is not always what fixed. Okay, now, and we want to do this by kind of asking questions. So maybe we can understand, or by asking these questions, you see that you're able to know or able to see the process of identifying the types of support. So now, when a column is sitting on a footing in the soil, what are the two main actions that can try to rotate that footing? And you have an answer when your column is what? Eccentrically loaded, and also when there is what? Lateral what? Forces. As you can see from the picture, the eccentric load and the lateral forces will now cause a rotation. And when there's a rotation, you see how your footing behaves. Here settles, here tries to, this edge tries to come up. And you're having what? Partial resistance and partial resistance as well. Okay. So eccentrically loaded means that the column is not loaded at the center, but somewhere away from the center. So, and it goes further to say an eccentrically loaded column creates bending moment at the base, which tries to rotate the footing. So this is the effect of eccentrically loaded column. Then the lateral forces create shear at the base, overturning moment and rotation. And rotation demand and the foundation. So these are the effects. This is the this now describes this picture. So this is how it behaves when there is an eccentric load or a lateral what force. Then the second question, if the soil and the footing can resist that rotation significantly, and that is why that question is very important. That is why it is in bold black. If the soil and the footing can resist that rotation, like say you have a vertically loaded column or lateral forces or anything that could cause rotation, right? Or overturning moment, all right? If you have any of those things that could cause such thing to your structure, then the question now goes on to say if the soil and the footing can resist that rotation significantly, will you expect the base to have to behave more like pinned or fixed? That is a very important question. You must have identified, okay, there is something going to cause movement, rotation. Then, with the your soil and and your footing, will they be able to? Can they resist it slightly? That means that what actually means that the soil and the footing cannot resist that rotation. So if they can't resist it, that means they allow rotation, right? And that allowing rotation is the behavior of what pinned support. And that is why you see that the answer is what pinned. Okay, so if you have a normal isolated power footing sitting on soil, not embedded deeply, do you think the soil can provide strong restraint? So what you have to know is what embedded, not embedded what deeply. So if it's not embedded deeply, you see that the soil cannot what provide strong uh, restriction or resist rotation. So in real life, soil cannot clamp a column like concrete does. So it means that soil cannot actually, hold column like when it's, when you know how concrete, how strong concrete is. So the soil does not behave that way. So these are the questions you ask yourself to actually determine if it's pinned or fixed. Okay. All right. So we have question 4. If overturning happens on a shallow, isolated footing, one edge lifts slightly. Can the soil provide tension to hold it down? No. Question 5. So if soil cannot take tension and part of the footing can lift under overturning, what does that tell us? So you see that it tells us that a typical shallow, isolated footing behaves closer to a pin base than a perfectly fixed base in real life. So as you can see, what is trying to tell you, if your footing is not deeply embedded into the soil, it behaves more of a pin support. But though we just mentioned the two types of support, pin support and fixed support. But we also have what we call the partial fixed. Like it's not completely fixed, but it is partial. So the partially fixed, we just take it as what fixed. So that also happens in your footing. You can also have your partially fixed because when doing construction, we normally have what we call the backfill. So, and also we have the surrounding soils around your structure. That is mean your structure is buried into the ground. So you see that at some point it is partially what fixed, not completely pinned, even though it is what isolated footing. Okay. So but a conservative design, we try to assume that okay, your isolated footing is what is pinned supported. Okay. And that could also be one of the reasons why some of your buildings that don't have plinth beams actually don't fail because being buried into the soil also provides the backfill, also provide what we call the partially fixed supported. So, but then if you make the footing larger, make it deeper, also we tie it with grade beam, which is your foundation of your ground beam, or with plinth beams, or we add pies. So, so when we add all those things, we see that we're actually making it hard for the foundation to rotate. So just like I've mentioned before, that some of the buildings without plain beams or your grade beams, which is your foundation beam, they tend to stand up to date. So, and I'm saying that one of the reasons is that the backfill is also doing something to your foundation. So some of these backfills also make the foundation partially what fixed and not completely what pinned. But now, if your beam is maybe okay, your foundation is pinned, so behaving purely what pinned supported, you can make it behave like what a fixed support. Okay, you can make it behave like a fixed support by providing what plinth beams, tie beams, or grade beams. You can also, when you have piles, it's also making it to be what fixed supported. And when you make your footing larger or your foundation goes more deeper, you see that your foundation behaves what more of a fixed support. So and that is why the plinth beam is very very important in construction. Even when you design as a structural engineer, you should also what provide your plinth beam in the sense that you have a soil test report or you understand that site, you know the nature of that site. Because from the soil test report, you're able to know whether you have clay, you have a loose sand, because clay automatically behaves what deforms, and that deformation causes what makes it what pinned supported. So by soil test report, you're able to understand how your foundation is going to interact with the soil, and by so doing, you're able to know when to provide clean beam or not. So it's based on your own judgment. Just based on own judgment, you're able to know or know when to provide your beams, your place beams. Okay. So as you can see, shallow or small footings behave like what a paint support, and providing beams to make it or behave fixed, just like what we have explained. As you can see, shallow or small footings behave like what? A paint support, and providing beams to make it or behave fixed, just like what we have explained. So now when you come to your software, if you model a shallow footing as paint instead of fixed, it is often what? Conservative for the structure, because of the paint there will be rotation, there will be kind of overturning or settlement, and once that happens, it will cause the moments in your columns to increase, your beam moment increase, the lateral drift. So by causing this things, your members are designed stronger. So and that is why we're going to compare this in product structure in part 2 of this video. We'll compare modeling the foundation as paint, model as fixed to compare the results, and also we model the paint support with a plate beam to see if you have the same results as when you model the foundation as a fixed support. Okay, so thank you for your time. Thank you for listening. Please do well to subscribe, like, comment, share to those you feel the knowledge is very important to. And also you can comment where or any aspect you want us to talk about. You can put it down in the comment section. In due time, we will talk about it. Thank you for your time.